Welcome to session HW148P, Scaling and Extending Windows Assessments to Improve System Quality, Part 1. I'm Patrick Azzarello, a Senior Program Manager on the Windows Ecosystem Fundamentals team at Microsoft. In this session, we'll be covering project goals and history. We'll start with the inception of the assessment toolkit, reasons for why we did the things we did, and why some of the existing solutions that were in the marketplace wouldn't work. We'll give a brief overview of the assessment tools we've included in the assessment and deployment kit, describing the process and components' interaction with each other. Next, we'll take a walkthrough tour of how the assessment is run, including the role of the tools, the infrastructure, and the assessments themselves, with a focus on showing you how it will scale from a single computer to a few systems to many computers. Assessment project goals and history. So this project started with a very simple customer request. Partners and customers want to assess and improve Windows system quality, and they want our help to do so. This was requested nearly across the board by our OEMs, ODMs, IHVs, ISVs, IT pros, and others. Now, in the past, our ability to do this was very limited as there were challenges that we just couldn't overcome in any specific time frame. However, with this version, we think we have a solution that will answer the needs of these partners and customers. So there have been past efforts that did address system quality. These efforts actually built the basis for what you're being shown today, but they had some limitations. So first, distribution was limited. Now, one of the main reasons for limited distribution was that these tests required additional training and were labor intensive. We just couldn't scale to support everyone that would benefit from the tool, so we had to keep the distribution limited. These tools were also harder to support and service. They were created with high quality, but for specific versions and to solve specific problems that Microsoft was encountering in the marketplace. They often were standalone, used different methods for running, configuring, and even providing error and logging information. These limitations translated directly into additional support and sometimes into user frustration. Now, what about the internal Windows tests in general? Now, they have their own challenges. The sheer number is daunting. It would be very easy to get lost just trying to find the tests you wanted to use, and thinking about how to navigate through that many tests, not to mention productize, distribute, and service them, was a major design consideration that we had to solve. Next, many of these internal test tools are relatively simple in design. They're command line tools with lots of command line arguments, and these command line arguments are often cryptic to utilize and understand. In practice, they function well, but are hard to use unless you have access to the team that built them, the source code, or the specific context in which to use them. Next, the scope of these tests. It's usually very, very specific. The focus is on a specific technology, case, or error, many of which are not interesting to people outside Microsoft. In cases where they are helpful to customers and partners, we deliver these tests in other kits like Windows Logo Kit. But when assessing overall system quality or user experiences, nearly every test is too small in scope and focus to be helpful on its own. We need to leverage these tests, but in a way that wouldn't overwhelm the user addressing and assessing system quality. Finally, to function at scale, they require a lot of internal dependencies. This is to make them efficient, but they don't translate well outside Microsoft. Things like test harnesses, setup processes, and other assumptions that just don't work when you take them outside the Microsoft environment. So in short, we needed to figure out a better way to solve these problems so that we could provide a solution to this customer request. So here are some of the project goals we came up with for this effort. We wanted to use user scenarios to drive these assessments with a focus on assessing the end-to-end user experience, not just the underlying technologies. We would assess the system quality in a quantifiable way, not just providing pass-fail or some score. We wanted to give you real metrics from the system so you could compare those results yourself as well. we wanted to allow for system comparisons. We also wanted to be able to identify and resolve issues, moving beyond what traditional benchmark tools do in the marketplace today into a place that not only identifies what's better or worse, but helps you make your own systems better. For the deep expert developer, system designer, or even the curious enthusiast, we wanted to provide the ability to dig really deep into problems with the Windows Performance Analyzer. Understanding that the ecosystem is vast and many organizations are involved in building Windows systems together, we want to provide a way for different organizations to leverage these tools and to share the information so they can improve them. This collaboration needed to support the entire life cycle. We started with Microsoft during development, and we hope this works through the OEM, the IT Pro processes, and right into the enthusiast's hands in the end. Finally, we wanted to make these widely available. We won't limit them to just a small set of partners. Anyone interested in system quality or system comparison should be able to leverage them. This means we needed to put an infrastructure in place to deliver, support, and service the assessments and the tools. This also means that we'll need to support a wider range of users with different experiences, different levels of expertise, and we also need for the tools to grow as the user grows. So we came up with the Windows Assessment Toolkit. All right, let's talk about the components used in the Windows Assessment Toolkit. So the Windows Assessment Toolkit is actually part of a bigger kit, the Assessment and Deployment Kit. With the ADK, you can install the apps and the assessments themselves onto your technician's computer to provide you with the ability to run these assessments. Now, we're specifying technician's computer to differentiate it from target computers. The technician's computer is the one that you install the assessment toolkit on. The target computers don't necessarily have to have the assessment toolkit installed, but they would still be able to run assessments. We'll talk about that a little bit later. So let's talk about the Windows Assessment and Deployment Kit for a moment. In this version, the Assessment and Deployment Kit replaces the Windows OPK and the Windows Automated Installation Kit. In addition to the traditional deployment tools, we've added more tools, including the Assessment Toolkit. We've also made the OPK easier to access and install, allowing for a more modular installation experience using an experience that is web-based. Here's a view of the ADK selection screen from the web installer. We also support the ability to download the kit installation components that you can download once and install many times, a necessary option for large organizations. Now let's go ahead and take a look at some of the individual tools. So, assessments, they're the bread and butter of the kit. They are what provides value to the customer, and without these it would be like having a Zune with no music or Word without the ability to save a document. The Windows Assessment Console provides a GUI front-end to select, configure, package, run, and view assessment results. This is the tool we'll focus on during the walkthrough later in this video. Windows Assessment Services is our solution for those that need a large, highly scalable, and automated lab infrastructure for running assessments. Finally, Windows Performance Analyzer is the new version of tools found previously in the Windows Performance Toolkit. It is used behind the scenes by assessments to collect and analyze data, as well as being able to drill into data deeper from the results file. All right, let's take a little time to understand the system in a little deeper depth and walk through a typical assessment run, including identification of the assessment, selection of the assessment, configuration, running the assessment, and viewing the results. Note that this is not a how-to demo, but an architectural walkthrough designed to help you understand how the system components work with each other. Here we go. So this is the home screen of the Windows Assessment Console. The Windows Assessment Console is probably the tool you're going to get started with and use most often. We have a couple of things available on the home screen. we have a list of pre-configured jobs. A job is simply a set of one or more assessments and the information that's necessary to run that or those assessments. We're not going to pick one of these pre-built jobs. We're going to actually go ahead and run an individual assessment. Here's a list of all of the assessments available on this particular machine within the Windows Assessment Console. This list comes from a mapping of the assessments to Windows Assessment Console through some registry keys. I'm going to go ahead and pick driver verification. I select it. It gives me a little bit more information. I can go down to the lower right-hand corner and click on Configure, and it will show me some more information yet. All of the information at the top of the screen, the metadata, is available to Windows Assessment Console through the assessment manifest. That's a file that's used to define the assessment to the tools. I have parameters I can set as well. In this particular case, I'm going to turn off the recommended settings, and I'm going to select the Windows Update option. The Windows Update option allows the assessment, or tells the assessment, once it has picked and found all of the hardware devices on the system, to go query Windows Update to see if drivers are available or if more recent versions of the drivers are available if there are already drivers on the system. I'm going to go ahead and click Run, give it a name. It is now going to use the user account control to get my permission to run. Why does it need to do this? Well, we're getting information about drivers. We need to run as an admin in order to be able to do that. So the first thing that happens actually isn't the assessment at all. It is the assessment framework. Right now, the engine is generating machine configure information, or machine configuration information. This information includes things like applications that are installed, hardware that's available on the system, the version of the operating system, and a lot of other information. It makes it easier to identify a specific system. It can also get some environment information in some specific cases. Now, the assessment itself has just begun to run. Here's a command window. It is just a command line tool that is running, but we are actually getting information back from the assessment, giving a status on what's going on. That is shown in this GUI interface. So as the assessment continues, the assessment is doing a number of things. It's setting up the system so that it can run. In some cases, a workload, which is a simulation of a user scenario, is running in the background. This is especially important in assessments like battery, where you don't want the system draining the battery just running it idle. We want it to act like it's actually doing something. The assessment itself is collecting data now. It has gone out to Windows Update, done a query of Windows Update, gotten that information down, processed, done the analysis, found problems, and created issues to show us what those problems are, and actually showed us the report that appears on the screen right now. Let's take a look at this. We have a little graph. We have some run information, which, if you notice, the name I gave the job is listed here, the time that I ran the job. I could have also put a little note in about the fact that this was run on one of the machines in my office. We have job parameters that are listed, and we have driver verification assessment parameters as well. In this particular case, I only set one thing, and that was the Windows Update flag to true. Let's look at the information I get back. We refer to things that are reported by the assessment as metrics. In this particular case, we have total errors and warnings on our summary page. Errors obviously are things that are bad. Warnings are things we should really look at. I'm going to go ahead and click on the driver verification link, and what we'll get is we'll get more information. If you notice, next to each of the values, we have red and green blocks of color. Those are stoplight colors. Green is good, red is bad. We don't have any yellow for the metrics here, but in this particular case, we set some thresholds and said more than 0 errors is bad, 0 errors is good. I can dig down even deeper and look at devices with driver updates available. This was information that I got through Windows Update. There are warnings here simply because, gee, you might actually want an older version than is available in Windows Update. This particular case, it tells us that there's a better driver. I'm going to move back for a second, and we're going to talk about the right side of the screen for a moment too. These are issues. The assessment has generated issues because it found problems. It tells us what the issue is. I'm going to pick this one. And it tells me there's a driver actually installed on the system, but it's not associated with a piece of hardware. It tells me how I can actually remove that driver, either online or offline, using a tool called DISM. We actually have a problem up on top with the problem code. It also gives us some other information about legacy devices, that there are better drivers available on Windows Update, etc., etc. So again, we're not just giving you the information, we're not just giving you numbers, we're trying to also identify issues for you and tell you how to remedy those issues. One of the other things I did was run the same assessment on other machines. I did it by packaging the assessment resources, putting them on a flash drive, and running this from a number of machines. In order to see those results, I can click on the Add Results pane. The Select Results window shows me all of the results that I have run on this particular system, but they're not on my main system. They're actually on my flash drive. I'm going to go up here, look through. I'm going to open up the job results. And now you'll see that I have 2 sets of results. I can do this again and again. And you'll notice that I get different results. I can go back up to a higher level and see summary information. You'll also notice too that there was another assessment run in the second job on the SH Bill machine. And that was the filing handling assessment, or so it says there. Anyway, so that's our quick run through of the Windows Assessment Console. We'll talk more about this later. Alright, so that's a demo showing you how the assessment infrastructure, the assessments, and the Windows Assessment Console work with each other to provide results and provide value on how to find and improve system quality. I'm going to take a little different view of things now, and we're going to go ahead and take a look architecturally at how all of these components fit together. So there are 4 basic phases to running an assessment using the Windows Assessment Console, our turnkey solution. We've included a 5th here to show you how to actually package the things you need to run an assessment to run on a different machine. So let's start with the assessments themselves. Assessments are the basic building blocks of the system. Think of them as tests, but in a non-traditional manner. The assessments aren't testing a single thing, as we talked about earlier, but they're trying to help you evaluate an experience. And many times, we identify problem causes and offer solutions to those problems. Now, these assessments can be simple, or they can be very, very complicated. In the end, there are 2 things that you need to have an assessment. 1, a set of assessment resources that include the assessment and any related files. This could be a single .exe, a script, or any other executable code. It could also include media content, configuration files, DLLs, or any dependencies that your assessment has. The other thing you need is an assessment manifest. The assessment manifest contains the information that's necessary to describe the assessment to the Windows Assessment Framework, which can then describe the assessment to the tools. Each assessment manifest contains a unique identifier, version, a set of requirements that it needs to run under, and other descriptive information, including servicing information. It also contains information that will make it easier to configure the assessment and defines the metrics or outputs of the assessment. It's an XML file, and you can actually build this in Notepad if you want to. Note that the assessment also creates results. It creates the values that get inserted into the results as defined inside the assessment manifest. We're going to talk about that a little bit later as well. So eventually, all these pieces that make up an individual assessment need to be delivered. To keep it simple, we just assume that all that is necessary for an assessment to run is in a single folder. When you install the assessment toolkit through the Windows Assessment and Deployment Kit, it installs these assessments as folders on the technician's machine. Now, in general, a folder is created for each assessment, though sometimes multiple assessments that share common resources can use the same folder. All right, so now we're ready to configure assessments into a job. We again do this through the Windows Assessment Console, which we just showed you. And the console uses the assessment manifest loaded through the assessment object model to expose what configuration options are available for that assessment, what the system requirements, etc. are. Any changes that you make are now stored in the job object in the object model. Now, just consider this a copy of the assessment manifest plus the values that are selected for the assessment and some information about the job. Once you're ready to run, you can save this job as a file. And we call this the job manifest when it's saved as a file. The job is always stamped with a unique identifier so that it can be identified downstream later on. So you can actually go ahead and create a job, send it out to a lot of your partners, get them back, and you can tell that it was the same job that you created earlier by this identifier. So also included in every job is a copy of the assessment manifest for every included assessment. This makes this job manifest more portable and assessment version specific. If you were to run this on a machine that already had the assessment and deployment kit installed, but a later version, and you were to run this job, it would use the settings as defined when you created the job, not the new ones that are on this new installation on that machine. And this was done to make these as self-contained as possible. All right, next is a minor step, but a very, very important minor step. This is what we consider to be packaging. Packaging basically allows you to create a job and then take all the resources necessary to run that job and run them on other systems. Let's talk about packaging an assessment in a little bit more detail. This is really important so that we can dive in deeper and you can really understand how you can integrate with your own systems later. So to run an assessment, you need three things: the job manifest, the assessment resources, and the tools to actually run that job. Packaging these so that they're portable is pretty simple in concept. The package is simply another folder that you're asked to specify and create during the packaging process. And this contains a copy of all that is necessary to run the assessment anywhere else, including computers that are running on a different architecture. That separate folder contains a copy of each assessment's resources. We copy the entire assessment resource folder, including content, etc. Note that one copy of each assessment's resources will be placed in the job package for each instance of that assessment in the job. If you have an assessment that you put in a job twice, we will copy the resources twice to the job package. Next, we need to modify the job manifest slightly. Right now, it's referencing the assessments as they reside on the machine where Windows Assessment Console is configured. We need those to be relative to the package, not to the original location on disk. Once we make those modifications, we actually add the job manifest to the job package. Next, we take architecture-specific copies of the tools and put them in the job package. Again, we want this all to be self-contained. Now, because the package is architecture independent, we need to find a way to select the right architecture at runtime. Now, this means that the architecture when you go to run the job package can be different from the one on which you created the job package. To do this, we create a file that we refer to here as the architecture script. This executes the right tools and assessment code using the system's architecture environment variable. You'll notice the %processor architecture %. When that gets executed, when we run that, it actually gets translated, in this particular case, into the x86 directory. We then take that architecture script and add it to the job package. Now, one thing to note here, although it uses scripting language, this file should not be thought of as a script that you will modify directly. Now, you can copy this package to a flash drive, to a removable media, or to a network share, and you can run the assessment from that location simply by double-clicking on the architecture script. All right, now we're actually ready to run this assessment. We found the assessments, we've created a job object which we turned into a job manifest, we've packaged everything that we need to run it on other machines. We've put it on a flash drive, we've gone over to the other machine. How do we actually run this? Well, the job package has that architecture script. You run the architecture script, it identifies the architecture of the system and runs the assessment. Now, that assessment is going to do a lot of things. It's going to set up the system. It's going to run workloads to exercise the system in a specific way. These workloads will simulate user activity, although other activities like system activities may also be run through the workload. It'll provide progress, error, and logging information. It'll collect data for presentation and/or analysis, and through the analysis, it will probably provide a list of problems and potentially remediation steps for those. All of this information will eventually wind up in a results file. Now, that results file will be viewable within the Windows Assessment Console viewer, or as we do with the Windows Assessment Services toolset, you can take that and you can import that into your database. The advantage of importing it into the database is you now have a rich collection of information that you can run various queries on, do data mining on, and find out all kinds of very, very interesting things about the systems that you're testing. All right, so let's wrap things up. First, we gave you a review of the assessment project goals and history. Then we described at a high level the changes in the Windows Assessment and Deployment Kit, as well as the tools delivered within the Windows Assessment Toolkit. Finally, we provided a walkthrough of the assessment architecture and components to show how it works and how it scales. We also recommend watching part 2 of this video presentation for more information on how to extend or customize this technology to integrate it into your own environment and meet your needs. For more information, please check out these other pre-recorded videos or the talks at this year's Build Conference. Thank you again for watching, and we hope to talk with you and hear from you soon.
Welcome to the Scaling and Extending Windows Assessments to Improve System Quality video session part 2. I'm Jason Cohen, a developer on the Windows Ecosystem Fundamentals team at Microsoft, and your tour director for the remainder of this video. Hopefully you have already watched part 1 a thrilling drama about an assessment infrastructure where you find out what it's made of and how it works day in and day out to configure, deploy, run, and visualize the results of all assessments that pass through it. In this stirring conclusion, you will discover how you can extend its potential by creating new assessments and automating their execution, as well as different ways to integrate them into your existing systems. As my friend Pat mentioned in the preceding video, we have built this system to be modular and provide plenty of places to plug in your existing tools or tests, and vice versa. We recognize that providing flexibility in integration and multiple extensibility points is critical to ease adoption for our partners. To enable this, we provide automatable tools as well as documentation for our APIs and schema for those that want to take things to the next level. In fact, the interfaces and schemas you can use are the very same ones we use to produce the assessments and tools delivered in the kit. I'm going to walk you through how to turn an existing tool into an assessment and how to automate its execution in a scriptable manner. I will also touch on things you can do with the results generated by the assessments. And I'll briefly mention some more advanced integration that is possible if you want to automate creating your own jobs. We all have test tools and frameworks that we've built up and come to depend on over time. In many cases, this will consist of a few command line apps that run in automated systems with complex scripts. To accommodate, we provide multiple ways to convert your tests into assessments, each involving a little extra effort, but also providing a greater return on investment. Most of you will want to run an existing command line tool as an assessment. This is done by creating an assessment manifest, which maps settings you want to configure to the command line arguments the tool already takes. Once you create the manifest in a folder with all the necessary resources and register its location, you will be able to view it in the assessment console, which is how you will configure and add it to a job. I will demonstrate this shortly. The real value of doing this work comes into focus when you also convert the output from your existing test into the results schema we have defined. Creating an XML document in this format will allow your results to be aggregated with other assessments that have been run and also displayed graphically in the assessment console. You are then able to easily compare multiple results from different runs. The schema also enables data to be easily imported into a data store of your own choosing. We make this easier by providing multiple ways for your tool to figure out where to put the results to get imported, including environment variables, which can typically be passed directly on the command line or used in a script, so no code changes to your tool are required. If you are building something from scratch or are able to modify your existing tools, you can take advantage of the Framework Runtime APIs. All the interfaces are provided natively to both .NET and C++ developers. Existing logging, error, and progress reporting you may already have can be provided to the framework in real time, making for a more consistent user experience. You can also enable the ability to cleanly cancel your assessment from the framework, as well as have access to many other helpful routines. As an assessment author myself, my favorite is the ability to easily check, backup, change, and restore common system configurations that your assessment may rely on. We highly recommend that once you get your assessment working, you take advantage of the reporting facilities to make it much easier for users to troubleshoot when issues arise. Now that you've built your assessment, why not share it? Just as our customers have requested our test, I'm sure yours have done the same. With a common framework that anyone can download and install, you only need to provide a simple installer for your new assessment. Just copy your assessment resources, including the manifest, to a folder, and add the path to the manifest in the registry, which I will now demonstrate. I'm going to start by tackling the simplest level of integration, creating an assessment manifest to wrap an existing tool. In this case, a tool most of you are probably familiar with, Ping. Since it is already built into the OS, all I have to do is craft just the right manifest to allow me to use the assessment console to configure and execute it. I realize this is a little like pulling the finished product out of the oven without showing you what went into it, but most of you will probably start with a sample manifest not unlike this one, and I'll briefly go over the changes you'll need to make to give you a quick taste of the assessment manifest schema. The first section is the version ID. The most important thing to do is create a unique GUID for your assessment and put it in here as I have already done. The version numbers that follow are fairly arbitrary, but you will need to make note of them for later. The AX version section should not need to be modified at this time. Next, you will see the first instance of a description section, which will become very familiar to you by the time we are done. This one is the description of the assessment. Each section contains a programmatic name, display name, and a full description. The assessment properties section contains some informative text as well as a couple critical fields. The processor tag lets you specify which architecture your assessment can execute on. This last property describes how your tool indicates success or failure to the framework via its exit code. This is another example of how the framework uses a simple existing mechanism most tools do already for quick integration. Even if your tool's exit code is more complicated, you can create a small wrapper script to remap the values. The parameter definition section is where we start to have fun. You are able to describe UI elements for the command line options your tool already supports. Here, I have taken the liberty of creating two parameters. The first is the host name to pass to ping. You'll notice again a description section with the same three elements as before. After that is the type, in this case string, followed by how the parameter is formatted on the command line. The curly brace 0 is replaced with the string the user inputs and added to the command line when the assessment is executed. For this parameter, it is placed directly as is. If the input string supports spaces, you may want to put quotes around the curly braces. The second parameter is the number of requests to send and is optional by virtue of not adding the required tag. It is of type unsigned integer, and when formatted on the command line, it is prepended with /n as shown here. This allows it to map to ping's existing behavior. The final required section contains the execution information. Here we specify that it is to be executed with create process on ping.exe in a new window. And there you have all the basic required elements of an assessment manifest. Now, for your assessment to show up in the console, we're going to need to register it. To do this, I know I'm going to need the GUID, so I'm going to make a copy of that. I'm going to switch over to the registry editor here, which I just so happen to have open to the right location. I'm going to create a new key. I'm going to paste in the GUID just like these other installed assessments. I'm going to further dig into one just so I get his example of what to do. I see that I need to create a second key with the version, which is why we noted that earlier when we were creating the manifest. And then I need to create, looks like, a path value. New string. And this is going to be the full path to my assessment manifest, which I can get over here. Now once I've done that, I should be able to close the registry editor and run the assessment console. And what it's doing is going to enumerate all those registry keys, and if I haven't made any mistakes in my manifest, I should be able to click on here and see my assessment. There it is. And when I click configure, that'll create a job for me with this single assessment in it. I can see the parameters now that I've defined. You can see this one's marked red because it's required. So I'll put a local server, which I know will respond to my request. I can even add another instance of this assessment. Again, I'll have to fill in a required field. This time I'm going to put in an internet URL. And because I'm behind a firewall, I know I won't get a response, so I'm just going to do it one time. Now I could click run, and it would execute the two assessments, and one assessment would succeed and the other assessment would fail that didn't get a response. But I don't get anything I can review results-wise other than the assessment passed or failed. So what I really want to do is take it to the next level. So I'm going to save this so I can come back to it later. Close the console, go back to my manifest. I'm going to open up a couple scripts which I've created. This guy here, he wraps ping, passes in anything that comes to him directly to ping, so we don't have to change any of our parameter definitions. But he's looking for a magic line called packets : and he's going to pull out two pieces of information, the packets that were sent and the packets that were lost. And it's going to pass that to the second script called ping results. Ping results just echoes to the screen XML in the same schema that we've defined for results. And it's going to print out the two values, the sent value with the first parameter and this lost value with the second parameter. Now this XML is going to be redirected to a file. This assessment results path is an environment variable that's set by the framework, and this is where we have to put our XML file. In fact, any XML files we generate there that meet the results schema will be aggregated into the Uber results file that's generated when the job is all finished. Now for good measure, because we want to fail only if the results are not generated, so if this line is not found, we will check to see if the file exists and we'll exit with an error code if it does not. Otherwise we'll exit cleanly and the test will succeed. Now that's not quite all I have to do. I need to define those two parameters, those two metrics that I just defined. So I created them in the results when they run, but I need to define them in my manifest. So I'm going to use the parameter definition section as a kind of a template because it's very similar. Instead it's called metric definitions. And paste it there without the S, and there without the S, and there with the S. Hopefully my squigglies go away. Yep. So I need one called sent. And this is going to be request sent. And it's of type uint32. Now I don't need the command line format because it's not a parameter, but what I do need is to tell the viewer what the units are. In this case, it's just a number. This could be anything that you can come up with, seconds, minutes, depending on what you're measuring. Here we're just sending a number request. Now I've got everything I need for that one, so I'm going to make a copy of it and add my second one, which is lost. So we'll change that to lost, that to lost, that to lost. Now, the one last thing we need to do is instead of running ping.exe directly, we need to run my test script. So we're going to change this to ping.test.cmd. I'm going to double check just to make sure I got sent, lost. Here we got sent, lost. Those all match. Ping test. Okay. Now, if I run the assessment console again, I should be able to open up the job that I've already saved. It should automatically refresh with the manifest that I've just modified. And we'll go ahead and click configure just so that we can make sure our settings are still here. I see that those URLs are correct. Now, again, I could run, and this time we're going to get a little bit different. Both tests will succeed because they've generated results, and when you dig into the results, you'll see one has lost none of the 4 packets and one lost one of the packets. But because I want to show you how to automate this stuff, I'm going to actually package the job and run it in an automated way. Now, this is something you might want to know for results path. Typically, when you automate, you'll probably want to change this to some network share. But for now, I'm just going to leave it to the local path. And then I'm going to need to select a folder where I can save this job. So I'm going to create a new folder called job. And what this is going to do is package everything I need to run this assessment. Now, I can take this folder just created and move it to any system and execute it. I don't need to register the assessment. That's only required for the console. To execute, I just need this folder. And you'll see here, the tools from the kit are in these processor-specific folders, and my assessment is in this folder. And what it did is it automatically grabbed all the files that were in the same folder as my assessment manifest. If I had subfolders, it would have grabbed those too. So when you install your assessment, just make sure everything's in one folder and it automatically gets put into this job. Now, I want to show you how to automate this, so I'm going to pop down to my command window. I'm going to go into that job folder, and I'm going to look at the run script that normally people would click on to run this interactively. And inside, I should see it's going to execute the processor architecture, and it's going to run the interactive assessment launcher. But I don't want to run the assessment launcher. I want to run this automated, so I'm going to run ax.exe. And I can see just ax.exe is very similar. It takes the job XML that's in this folder to run. Now, while the job gathers up the machine information to store in the results, I want to note an important thing to consider when using ax.exe in your automation. In order to support all manner of assessments, you won't be able to fall back on the tried and true launch ax.exe, wait for it to finish, and then move on to your next task. This is because some assessments are more complex and do things like reboot the machine to gather their metrics. Obviously, in this case, all the processes would go away and your automation would be halted. Not to worry though, we have your back on this one. The framework already supports these types of assessments, and you just need to know about a job parameter you can add to the XML called post-execution action. This specifies the tool or script which we ensure is run when the job is truly all done and is safe to continue your automation. Now we can see here This job is truly all done because it was a simple assessment, and you can see that it's finished and it has executed 2 assessments. None of them failed. You saw the command windows pop up of the ping assessment running. Now you can also see here the path to where the results are published. This is information you would have in your post-execution action. You could copy those results to wherever you want, or you can actually have them published as part of the job. But what I'm going to do is go back over here, and I'm going to open up the results, and I should, because I publish them locally, I should see the results right here, which I do. I'm going to say OK, and you'll see here I have my 2 assessments that ran. I have my 2 metrics that I've created, the sent count and the lost count. You'll see the first one succeeded all the time, and the second one failed the one time. So that should give you just a little taste of how you can create and run your own assessments with minimal effort. Now, as we have mentioned before, you could install the assessment and deployment kit, and with a turn of the metaphorical key, be off and running, automating assessments on one, a few, or even many machines. But those of you still watching probably have quite the infrastructure set up already, and you will want to take things piece by piece. I've just shown you how you can automate jobs with our console tool and pointed out key parameters in the job manifest schema, which will aid in integrating into your environment. I highly recommend taking a closer look at the Ax.exe help and the job manifest schema for other helpful features. But if you find the need to integrate more fully than the tools will allow, you can take a look at the documented solution APIs. These are the same APIs that are used by Ax.exe and the assessment launcher, and allow a greater range of support for executing assessments. In fact, with the managed versions, you can even execute a job directly in PowerShell, which I can briefly show you. Now, I'm not going to go into too much detail, but this gives you a quick example of how you can do the same thing I just showed you with our tool, but in a PowerShell script. The first thing you have to do is load the managed runtime and solution APIs from Microsoft Assessments Core DLL. Once you have that loaded, you can initialize the solution, and from the solution, you can create a job from a file, as well as create an engine from the solution directly to execute that job. Then after I set a few parameters so that the framework knows how to execute me again in case the assessment reboots, I can execute the job. Once the job is finished executing, I can print out the information that's returned to me. And it's as simple as that for those of you who are well versed in PowerShell script. From here, you can customize it even further. Now you have the ultimate in flexibility when executing assessments. As you saw earlier, the easiest way to view and compare your results is in the Assessment Console Viewer. It has the ability to export to Excel, which I find particularly useful for more detailed analysis. Everything you need is contained in the aggregated results XML file. It is your one-stop location for what you need to know about the job that was executed, the assessments that were used, how they were configured, the metrics, issues, errors they generated, as well as a lot of useful information about the machine they were run on. The schema makes it ideal for importing into the Windows Assessment Services data store, or perhaps your very own. It's even possible for you to use the APIs and schema to create a viewer on your own, but I really think you'll find your expertise are better spent analyzing the data. It is worth mentioning that the managed administrative APIs, which the Assessment Console uses, are also documented, and you could create your own tools for authoring and packaging jobs. For example, Microsoft has an internal test tool that utilizes these APIs to run assessments directly by creating a job on the fly using the assessment's defaults along with its own configuration parameters. However, I think you'll find it is sufficient to create a few jobs up front and then tweak most of the common settings when you execute them. Well, by now you probably have a few ideas on which parts of the assessment infrastructure will fit nicely into your existing test environment. This list summarizes our main recommendations, along with a few sub-bullets for you overachievers out there. As you start to dig into the documentation and experiment, if you don't find a convenient way to do something, keep looking. In many cases, there is more than one way to plug something in or to get something out. It isn't that we couldn't make up our minds, we just found that there are different strokes for different folks, and we wanted to make it as easy as we could for as many as we could. If you haven't already, I hope you take the time to view the other related talks and videos available at Build. Also, check back frequently for updates to the documentation, which will be made available on a regular basis through and beyond release. Again, I'm Jason Cohen, and thanks for watching.